about some examples of shifting transformations on functions. And we'll start with this function here. We have y equals f of x and we're given this graph. Again, we don't have an equation for this function, but that's fine. We have the graph and we have two important points on this graph. So if we can shift those 2 points, the rest of the graph will kind of follow along. So let's look at this one first. Let's look at f of x plus 3. So again, we're shifting the input in this case. So this is the one that's counterintuitive. It's not going to move to the right 3 like we kind of think intuitively it would. It's going to move to the left by 3. So there we go. We know that this one is going to move to the left by 3. So I can take each of the points and move them left 3. So 2, 0 is going to become negative 1, 0. And 0, 4 will become negative 3, 4. So we can draw in the rest of our graph. It all comes along. And we get the same graph, just moved over 3 units. To the left in this case. So this is y equals f of x plus 3. Now let's think about the second example. We have f of x minus 4. In this case, we're working with the outputs. We're shifting our outputs because we're not inside the f of x. So the negative 4 intuitively is going to move the whole graph down 4 units. So the 2, 0 will become 2, negative 4. The 0, 4 is going to actually become 0, 0. Because if I take away 4 from 4, I get 0. So there's our graph of y equals f of x minus 4. So here we had one horizontal shift and one vertical shift. We moved one to the left 3, we moved the other one down 4. So let's investigate a little bit what will happen if we actually do both at once. So for our third example, let's think about what happens if we have y equals f of x minus 1 plus 1. So in this case, we're shifting both our input and our output. So if we think about what happens with the input, we're actually moving it to the right by 1 unit. That's what the x minus 1 tells us. Then, if we look at what happens to our output, we've added 1, so we're going to move up by 1 unit. So let's graph that. Often when you're getting used to these types of shifting functions, it actually is easier if you do them one at a time. So let's think about doing our input first, input shift first, and then our output shift. And I'm going to draw the first one as a dashed graph, just so we see that that's not our final answer, so we remember we have to do one more thing. So first of all, I want to move the whole graph right by 1. So I have 3, 0, and then I have 1, 4. So I'm going to dash this one, remember, or make it dotted. So remember that I'm not done. I still need to move it up by 1. So this point is now 3, 1, and this point is now 1, 5. So in the end, our new graph will look like that. So see that we've shifted the whole graph to the right by 1, and then we moved it up by 1 to get our graph of y equals f of x minus 1 plus 1. Let's do one more of these where we have to do 2 different things. Let's take y equals f of x plus 2 minus 1. So again, we have two different things we have to do for this example. We need to deal with our input shift and also the output shift. So our input shift is going to tell us that we're moving to the left by 2 units, right? Because we're adding 2. The output part is going to tell us that we're moving down by 1 unit, since we're subtracting the 1. So first of all, we want to move everything left by 2 units, so that means 2, 0 becomes 0, 0, and 0, 4 becomes negative 2, 4. Again, I'm going to dot this one in. We're not quite there yet. We've only done one of the 2 steps. Then I need to move all of that down 1. Now, if you're feeling like you're comfortable with drawing these graphs without taking it step by step, then that's fine. You're welcome to do this all in one step. It's just, I find it a little bit easier if I do it step by step, at least until I get comfortable with it, so that I make sure I'm doing everything right. So there are some examples based on this graph. We horizontally shifted, we vertically shifted, and then we did some where we had to do both. Now let's think about some quadratics. Remember, our base function for quadratics would be f of x equals x squared. And our graph of that hits its minimum value at 0, 0 and is a nice parabola shape. So let's think about, what if we took our new function to be x squared plus 7, and I wanted to graph that based on my function f of x equals x squared. Well, in this case, we have that x squared in there, right? And then we have a plus 7. So what this looks like to me is just y equals f of x plus 7. So we're just adding 7 to the end, meaning we're shifting the whole function up. We didn't actually do anything at all to the input. So if I want to graph this parabola, this quadratic, suddenly instead of being at 0, 0 for my minimum value, it'll be at 0, 7. I've just shifted my whole graph up by 7 units. So that one was pretty easy. Every once in a while we do get a quadratic that's not as complicated as we think it's going to be, because we can just move it up or down when there's nothing going on with the x, the input. Okay, let's do a couple more things. So let's take, working based off of y equals x squared, or f of x equals x squared, let's look at the function x squared plus 2x plus 1. Now remember that in this case we're actually looking to get this in the form x squared plus 2xs plus s squared. That's our goal, because we want to be able to factor that to be x plus s all squared. So let's see if we can do that. We have an x squared, good. We have 2xs and 2x. So in order to make these two terms the same, s is going to be 1. So we have we need an s squared now, but s is 1, so our s squared is 1. Well, if we look at this, we see that our original equation, it already had that plus 1 there. So this was an example a function that was actually already given to us in the correct form. We already had that x squared plus 2xs plus s squared form. So we could actually immediately go from here to here. We can factor that to be x plus 1 squared. So based on x squared now, we see that we're shifting our input by adding 1. So that means the whole parabola is going to shift to the left by 1. And it'll look like that. Okay, one last example. Let's take y equals x squared plus 2x minus 1. So notice that this does not have the form we want yet, right? Because it's always going to be plus s squared, and here we have a minus 1. That's never going to be plus a square, because we can't get a negative square. So we need to do our completing the square here. So we've already established that s is 1 in this case. So we need to add 1 so that we have our plus s squared. Then we need to subtract 1. And then I need to remember to bring this subtracting 1 that's already in my function down there too. So these guys just become 0. I'm adding 1, subtracting 1. I'm not changing the equation at all. And then this one came from my original equation. So I have x squared plus 2x times 1 plus 1 squared minus 1 then minus another 1. So again, I changed this plus 1 into plus 1 squared because it's the same thing. My minus 1 from subtracting off the one I added essentially is here. Then I have my minus 1 from my original equation. So this should come out to x plus 1 squared, just like it did over here, except now I have these minus 1, so I get a minus 2. So in this case, we're shifting the input to the left by 1, and then we're shifting down by 2 from the output. So we would go left 1 and down 2. So there would be our minimum value. So -1, -1.